In this tutorial, I will be demonstrating how to navigate through all the display windows to get the information you need for manual analysis. This is the view once you load all the data with the MS Pathfinder search results. In this display window, the left column shows all the proteoform identifications grouped by the protein name. And if you expand the protein trees, you'll see the individual proteoforms. If you click on any one of them, it will actually navigate to the specific scan. And if you keep expanding them, you'll actually find the proteoforms grouped by different charge states. The main window is the spectrum view, which shows the LcMS spectrum. If you loaded the search results, you will have all the annotations, and all the matched fragments will be displayed here. On the right, it shows the previous MS1 spectrum and also the next MS1 spectrum for this LcMS fragmentation spectrum. For a good match, you should have both the MS2 matched very well and also the MS1 precursor matched pretty well. By default, this display window is exactly your isolation window you set in your acquisition method, and is centered around the mass you selected. This helps you determine if you have co-isolated some other proteoforms in your experiment. And in this case, this is a very good isolation window, isolating mostly just a single mass species. If we click on this button, it will actually switch the views. The middle window is the sequence view showing all the matched fragment sequence coverage. You can move the windows around, resize it, to see the different regions. The bottom table is the scan view, which shows all the scans from this analysis. This table is interactive and you can click on any of the columns to reorder the entries. For example, I will just reorder them by scan number. There is also another function to filter. If you right-click on any of the headers of the column, you'll see this filter function. By default, it will filter the results by the Q value, and also the unidentified scans will be removed by default. If you click on those entries in the scan view, it will actually navigate you into individual scans. And all the windows up here will be updated. In the sequence view, if you right-click, you'll be able to save this as an image for publications or presentations. In the spectrum view, if you right-click, you'll have a lot more options to choose from. For now, I'll just be focusing on the display options. One of the important things is to pick the specific ion types. So by default, the LcMsSpectator will pick the correct ion types for specific scans. For example, the HCD spectrum will look for B and Y ions, and the ETD will look for C and Z ions. And this can be actually changed if you need to in the settings here. The default ion types will define which ions it will look for. If you want to zoom in to a specific region of the spectrum, just move your cursor in the spectrum and then use your middle mouse button to scroll through. By default, the y-axis is fixed and it will automatically normalize to the highest peak in the view. If you want to unlock that, right-click and uncheck this automatically adjust y-axis. Now, if you roll your middle mouse button, both x and y-axis will be zoomed. Right-click and hold, you can move things around. If you move your cursor to the x-axis and then move the middle mouse button, you will only zoom in the x-axis. The same applies if you are panning. Use your right mouse and hold. The same goes for the x-axis. If you need to more precise display on specific region, say in this case, if I want to zoom in precisely at 300 to 1500, I can right-click and click on Show Manual Adjustment. And now you'll see it opens up new windows that I can actually put in numbers. And then you can precisely set where you want to display the beginning and end of the spectrum. The same goes for the y-axis. In here, you can also save this as an image or export the peak list. If you click on the spectrum when it's active, when you press Ctrl+C, it will actually do the same thing and copy the spectrum into your clipboard. Next, I'll show the XIC view. The zoom in and zoom out function is the same as the spectrum view using your middle mouse button. And same also for panning is to use your right mouse button and click and hold. This, by default, displays your selected proteoform, and you will display all the extracted ion chromatograms for different charge states, centered around the charge state you selected. For a good proteoform signal, you should see very similar chromatogram for all the charge states. And the dashed line shows where the MS2 scan is. The third one is the feature map. And this shows all the proteoform features based on their deconvoluted monoisotopic mass and also the retention time. And when you select a proteoform or a scan, you'll see a green rectangle highlighting that scan, the location of that scan in the feature map. And the zoom in, zoom out function and panning function is exactly the same as the other windows. You can use your middle mouse to zoom into the region you want to see. The display may be lagging a little bit, so please be patient when you're using this, especially when you are dealing with large files. So now you can see very well that feature is being selected here, showing you where this proteoform is in the LCMS feature map. If you left click and hold, it will give you more information on the feature you are selecting. There are several other options that may be useful for the feature map. If you right click, it will give you a few other options. The show manual adjustment is the same as I was showing for the spectrum view, where you can set specific regions you want to display. What's useful is the show identified LcMsSpectator scans and show unidentified LcMsSpectator scans. If you click on this, you will put crosses on the other identified LcMsSpectator scans. For example, if you see this proteoform feature shown up here, and you do want to figure out what this proteoform is, when you display this, you will know that there is a LcMsSpectator identification associated with this feature, and you can try to find that manually to figure out where this feature is. When you open the unidentified LcMsSpectator scans, you'll see the small dots on the features that has LcMsSpectator data, but it has not been identified by LcMS Pathfinder. At least you know there is data associated with this feature, and you can manually go in there and figure out what they are.